Assalamualaikum students. Today we are going to discuss sampling distribution of sample means. So to study the link between sample mean and the population mean, first of all we have to use the notation x bar and mu because with the help of sample mean we can approximate population mean. So the sample mean notation is x bar whereas this mu represents the population parameter. Now, first of all, I would be taking a population of 5 values in that. So we need to denote n equals to 5. And let's suppose that the numbers included in the population are 80, 82, 85, 88, and 90. So assuming these numbers belong to the population, what we need to do, we need to first compute the population mean because we are in a process to establish a connection between x bar and population mean. We will also see that what is the relationship between the sigma of x bar squared with the population variance. So if this sigma of x bar square is again representing the variance of the sample mean values, whereas this sigma square represents the population variance. So first of all, we would go for computing the population mean mu, compute mu and sigma square. And for this, what we would do, we would be taking x values and the formula for mu is summation x. Here you can notice one thing that I am using upper cases on the right hand side of the formula. This is what the norm is to represent population parameter rotations. So this uppercase of x is representing every observation that belongs to population, whereas this uppercase of n in the divisor is representing the size of the population. So what we need to do, we need to add all the observations together first. So I'm going to list all the values. Here I will write down 80, then we have 82, then we have 85, then we have 88, and then we have 90. So what we would do, we would add them all. And what is the sum that it would give us when we all add all these given numbers or values? It would give us 425. So 425 is the sum of all the values that we have added together. So 425 divide this by 5 would give us 85 as the population mean. Over here, I will focus on one thing, important aspect of the data. If we look at the central value that we are given in the data is 85, and if we have a close look on the values given as the neighborhood values of 85, 82 is at the same distance similar to 88. So 80 with respect to 85, 82 lies 3 values below 85, whereas 88 lies 3 values above 85. Similarly, if we compare 80 and 90, that are the minimum and the maximum values given in the data. So 80 is 85 units is 5 units below as compared to 85, and 90 is 5 units above as compared to 85. So this data contains symmetry, and in symmetry we observe, or we can generalize this opinion, that both mean and median have the same values. So for median, what we need to do, we need to arrange the data in ascending order. I have taken this data arranged in ascending order already. So what is the middlemost number representing? The middlemost number over here is representing median, and since the data are symmetric, therefore we will get the same value as the mean value, and this is what you can see. Now to compute variance, which is of the population, we make use of this formula, and what we need to do, we need to take away mu from each value of x and then raise it to square. So 80 take away 85 is minus 5, minus 5 squared would give us 25. 82 take away 85, which is the mean value, gives us minus 3 squared is 9. Similarly, 85 take away 85 gives us 0, and that would give us 0. Then 88 take away 85 gives us 3, squared is 9. Again, 90 take away 85 would give us 5, squared is 25. Now, we would add these numbers and we would be getting the sum of 68, and we substitute 68 in place of summation x minus mu whole squared, and to get the average we need to divide it by 5, and this is how we get 13.6 as the population variance. So this is how we have completed the first part of the question, that is computing the population mean and the population variance for a given population of size 5.